welcome to Mrs. Miller's Math Game Show, where math will turn into a fun, exciting subject for everyone. So, ladies and gentlemen, get ready to rock this show.
Okay. How are you guys doing today? Yay! Okay, good. So, we spent some time learning how to solve systems of equations in our last video, which was with second period, and I will say for the record on camera, third period is upset that I cheated on them with second period, but it was not the same. It was not the same. Okay, here we go. We're back to third period again. All right. It's like really warm in here today. Ready? Yeah. So, you guys learned how to, let's make sure we're all adjusted. Good. Now, we learned how to solve systems of equations by graphing them on Friday, right? Right. So we figured that we graphed each line and we saw where the lines intersected, and that was where the solution was. So today what we're doing is actually solving these in a way that does not require graphing. What do you all think about that?
Yes!
Okay. Woo! In fact, this is the best way of solving ever. So here we go. We have negative 2x plus y equals 6 and 2x plus y equals negative 2. So negative 2x plus y equals 6 and 2x plus y equals negative 2. All right. So again, if we were looking at the way that we went about this before, can somebody just refresh my memory what we would do to solve this if we were doing it like we did on Friday? How good are you on people's names? If I say their first names, are you good? We have a new person keeping track of ours. I can call, should we switch it up? Should I call you guys by your last names today?
Oh, no.
Yes. I know everybody's last name, first and last. And you know what's sad? I have 125 of you, and some of you can't keep track of my name. You have 7 teachers. That's, yes, exactly. I don't know. Okay, I've heard it all though. All right, so, what do you think? Last names today? Should we switch it up? All right, ready? I can prove it. I will prove to all of you that I know your last name. So here we go. Anderson. How did we, oh, he's, okay. Go ahead. How did we, what did we do?
Okay,
He's snapping to remember. Good.
Never mind, so I'm going to have to refresh my memory.
Okay. Barry.
You have to get the y by itself, so for the first one, you would plus 2x.
Excellent. Give it up for Shuggy. Give it up for Shuggy. Yay. Barry. Give it up for Barry. Okay, thank you. All right, so what she said was we would get the y by itself, find the y-intercept, the slope, graph it. But we are not doing that today. Here, yay, I know. Nope, this is easier. So, clap or make some noise if you agree that you can see that with these two equations, the x's are lined up. Clap if you can see that. Okay, clap if you can see that the y's are lined up. Okay, and how about clap if you can see that the numbers are lined up. All right, so this is how easy this is. We are going to add these equations together. So, can somebody tell me when I add negative 2x and 2x, what happens? Rosler. Shh. You get, that's good. Give it up for Rosler. Good. Now, how about y plus y? Shout it out. What's y plus y?
2y.
Excellent. What is 6 minus 2?
4.
We all better know that. Okay, now, what do I do to get, so look, we have an equation where we only have one variable, Casho. Is that how you pronounce it, Casho?
You're the only teacher that pronounced it right.
Yay for me. Okay.
Divide by 2.
Good. Give it up for Casho.
I don't know.
Casho. We can even cheer for Casho. Okay, now what? So we have y. Can anybody make a guess as to how we can use this y to solve for the x? Iniguez? Is that how you pronounce it? Okay, how do I do it? Iniguez? Oh, it's not too off. Go ahead. Iniguez. Good. Give it up for Iniguez. Yay. was, everybody exhibit? What she says was we take the y and plug it into either of the equations for x. So, does it matter which one? No. So, pick one.
Bottom one.
The bottom one. Okay, 2x plus, ooh, and with enthusiasm, no less. That's good. Okay. So we plug that in, and we get 2x plus 2 equals -2. All right, so can somebody walk me through the steps to solving this for x, getting x by itself? McDonald. That's you thing.
Never mind.
Or not.
I forgot what I was doing. Oh wait. You would subtract.
That's good. What?
Subtract -2 by 2.
That's good. So,
-2 by -2.
so what's -2 minus 2?
That's -4.
Good. Okay, and then the last step?
Is to subtract -2 -4.
Or this is saying 2 times x. What's the opposite of multiplication?
Division, so you divide -4 by 2.
Good, and what does that come out to? -2. So we get, remember we want to put this in coordinate form at the end. The x coordinate always comes first, the y coordinate comes second. So what is our coordinate? So can somebody tell me what the coordinate is?
-2.
-2, 2. All right, everybody give yourselves a round of applause. It's a good team effort. Okay, questions. Wasn't that a lot easier?
Yeah.
Cool. All right, so let's move on. Does everybody have this? Can I move it?
Yes.
What's up, Casho?
Weren't you supposed to add 2? Oh wait, no, I was looking at yeah. Supposed to add 2.
Right here? Here?
No, because you put -2.
Yes. Right. -2 minus 2. Is that?
Oh.
It's not -2 times 2.
No,
Oh.
If you're adding it to both
Okay,
sides,
everybody exhibit so I can hear.
if you're trying to get it to the other side, or
You do the opposite of what's being done. So it's 2x plus 2. The opposite of addition is subtraction. Very good. Okay, other questions? All right, let's do another one. We're going to make today an extra credit day again. Yay. We like extra credit days here. We've got 2x plus y equals 6. And x minus 3y equals 4. All right. 2x plus y equals 6 and x minus 3y equals 4. All right, so let's just look at this. We have all the x's lined up, we have all the y's lined up, and we have all the numbers lined up. So in this one, if we were to go about it the same way we did in the last one, you guys tell me, would anything cancel out with these two equations? No. Okay, so now we have to resort to something else. Anybody have any idea what we might be able to do here so that something cancels out? Martinez. Okay. Excellent. Give it up for Martinez. So if the camera did not pick that up, what she said was we multiply the bottom equation by -2. Martinez, what would that accomplish? That would cancel out the x's. Good, because -2 times x is -2x, and then they go away. Now, let's suppose, just for the sake of looking at this, we wanted to cancel the y's out instead. Can somebody make a suggestion about what we might multiply by what to get those y's to cancel out? Okay, Suspia. Is that right?
Yeah.
Yay! Okay.
Multiply the top by 3.
Excellent. Multiply the top by 3. Give it up for Suspia. Okay. I do not know middle names, though. People ask me that all the time. I do not know anybody's middle names. I know first and last.
Spells lying backwards. Lorenzo spells lying backwards.
Okay, that's good. All right, so if we were to multiply the top equation by 3, then the y's would cancel out. So, which one do you guys want to do?
I want the top.
Here's what I want to do. I'll tell you what I would like to do. I would like to multiply the top by 3. Why would I choose that? They're both equally accurate mathematically. So why would I say 3 is preferable to me? Any ideas? Rosler? I have a thing for odd numbers. I do not have a thing for odd numbers. Nice try, though. Good. Ramos? No? Okay. Let's take a look at the fact that this y is positive and this one is negative. we don't have to worry about negatives here, because if this one's already positive, this one's negative, so we just have to multiply by the number itself and don't worry about the negatives. As opposed to here, they're both positive, which means we have to make sure we include a negative. Okay, so let's do it that way, but again, each of them is mathematically accurate. All right, so if we distribute that, can somebody tell me what we end up with as an equation? I'm going to rewrite the whole system down here, but can somebody tell me when I multiply that 3 all the way through on the top, what I end up with?
6x.
All right, Crawford, go for it.
6x plus 3y
Uh-huh.
equals 8.
Everybody give it up for Crawford. Yay. All right, cool. Now, you guys can see if we add them together, something does cancel out. Yay. All right, so can somebody tell me what we end up with when we add these two equations together? Casho?
You get,
So what happens to the y's first?
they cancel out.
Good.
And then you get 7x equals 20.
22, that is unfortunate. Is 22 evenly divisible by 7? No. That sucks is what the response was by the crowd. Yes, true. Now, most of the time, you will not get fractions when you're dealing with systems of equations. But every now and then they pop up, and there's not really much we can do about it. So if we divide by 7, we get x equals 22 sevenths. So just like in the last problem, what do we do with that 22 sevenths? Barry?
Well, we showed it in the equation, but I was just wondering, does it matter which?
No, doesn't matter which. Pick one.
Let's go with
X
x minus 3y.
minus 3y equals... All right, everybody, we have not given everybody props for participating. Everybody give everybody props for everybody who has participated.
Yeah.
Okay, so we plug it in. We get 22 sevenths minus 3y equals 4. Whoops, we're getting dim. All right, now, thinking back to the very beginning of the school year, I know that was so long ago for all of you, but does anybody remember how we get rid of the fraction in here? Crawford?
We have to make everything have the same variable.
Something like that, something like that.
Or we could make it into a decimal.
I hope we don't want to make this into a decimal.
Why not?
Because decimals are not anywhere near as fun as fractions or whole numbers, and we want to get rid of fractions and decimals. Ordona, did you have your hand up? That's you.
Oh, yeah, it is.
Why are you looking around for another person with...
Like,
Okay, go ahead.
We would have a common denominator.
Is that how you pronounce it? What? Ordonia. Okay, so if we look at the denominator here, give it up for Ordonia. All right, if we multiply everything by that denominator that we have, what happens is we get rid of the denominator, we get rid of the fraction. Okay, so we did this before. Everybody in the crowd is looking surprised, like, what are we doing? We did this back in the beginning of the year. That is scary, you guys. That was only like 6 weeks ago. Okay, yeah.
we've been too long. What is the break?
Okay. Did you pick that up, camera? Crawford is ready for a break. Okay, here we go. So, what happens to the sevens in this first fraction? They cross out, and we're left with what, Ordonia?
22 over 1.
22 over 1, okay? Now, I'm going to keep going with you, okay? What's 7 times negative 3y? Negative 21y, and then 4 times 7 is what? 28. Everybody give it up again for Ordonia. Okay. All right, now, somebody walk me through solving this for y. Crawford.
Subtract 22 from both sides.
Good. I'm going to keep going with you till the end, and then we will give you your props. Okay, 28 minus 22 is?
It's 6.
Good. And then what do we do to both sides?
Divide by negative 21.
Good. So y equals, now, is this something that we can reduce? Yes. Is there a number that goes into both 6 and 21? 3. So if we divide by 3, we get negative 2 over 7. Perfect. So can somebody give it up for, everybody give it up for Crawford. Okay. Now, in coordinate form, what's the answer? Somebody tell me what the answer is in coordinate form. This is an extra credit question, you guys.
It is.
And they all are. Montanez. Montanez, thank you. Good? That -2/7. All right, everybody give it up for Montanez. And everybody give it up for me for knowing everybody's last names. Okay.
You should just go through the room and point at like.
No, you should just call us by our middle names.
I can do that.
Do it.
And I can do it on camera if you guys
Do
want.
it.
All right, here we go. Here is my contestant problem. Ready? Nope, we're not done. Not done yet. I know how much you all love these notes, so we're going to go through 19. All right, so this is the problem that I'm going to ask for a contestant on. We have 2x plus 5y equals 0. I mean, I know you all love seeing me up here all the time. You really do. There is sarcasm in that, in case you did not pick it up. But let's get somebody else up here. All right, so everybody try this out. We will be right back. Okay, we are back with our contestant. We have Celorio coming up to show us how to solve this problem. Everybody give it up for Celorio.
All right.
Whoops.
Yeah. Here we go. I'm talking about man. It's my favorite class. It's a pain in the butt. So what? So what? I'm talking about right. That's my favorite class. It's a passion in the butt. So what? So what?
So, we need the numbers, talking 1, 2, 3, because if we didn't have math, they could charge us hidden fees on our cell phone bills, and even on our taxes. All we gotta do is put in a little practice, from the plumbers to the teachers, and even the physicians, the doctors and the lawyers, and even the musicians counting down. Like 1, 2, 3, 4, we can hear it on the beat and even read it on the score. Some say a waste of time, what are they doing it for? So they ain't no end up again in this, sweeping up the floor. Shout out to Miss Miller and even Mr. D, Miss Barnett, and Mr. Humphreys from Algebra 2 to trigonometry. If it wasn't for math, where would we be? Shout out to Miss Miller and even Mr. B, Miss Barnett, and Mr. Humphreys. Hi.
Okay, everybody give it up for Celorio. Okay. Cool. How are we doing on questions, you guys?
Good.
Good?
Yeah.
All right. We have one last one.
Oh.
Everybody do that together. Oh. We thought we were done. Surprise. Okay. Last one. This is really short, though, I promise. Okay. So, x equals 3y, and x minus y equals 8. Now, the title of our notes is called Systems of Equations, Addition and Substitution Methods. Now, can anybody, if we were to look back at our other examples, can anybody see where substitution may have come into play? Where did we use, we've already used substitution a bunch. Montanez.
Where do we
Yeah.
when we get either x or y, then we put it in.
Excellent. Everybody give it up. Right, give it up for Montanez.
Yeah.
So everybody give it up for Montanez. Okay, so she said whenever we solve for and get one of the variables, then we take it and substitute it back into the other equation for the other one to get the other one. All right, so in this case, we have x equals 3y and x minus y equals 8, right? So can you guys see that this one's a little different than the ones that we've done so far? Yeah, though they're not really lined up the way they have been. But we do see that we have a variable by itself. X equals 3y. Just like in the past, we've gotten x equals 5 and then plug that 5 in. Well, if x equals 3y, we're going to take that 3y, plug it into the other equation where there's an x, okay? So we get 3y minus y equals 8. Questions on that? Right, because x would equal x, exactly. Everybody give it up for McDonald for that observation.
Yeah.
All right,
Oh.
so what is 3y minus y? 2y. 2y equals 8, and then how do somebody tell me how I solve this for y? Divide by 2. So y equals 4, and then how would I go about solving for x? De Guzman.
Plug it into the x equals 3y.
Excellent. Everybody give it up for De Guzman. Yay. What is 3 times 4, everybody? 12. All right. The easiest extra credit point ever. What is my final coordinate? Hopkins. 12.8 or 12.4, perhaps?
12.4.
Excellent. Everybody give it up for, it's actually Babcock Hopkins, right? Hopkins? Oh. Okay. Everybody give it up for Hopkins. Yay. All right. Questions? Anybody have questions? All right, we are on our homework. Homework 22, page 166, numbers 3 to 21, 3n, that means multiples of 3, and 31 to 35 odd. You guys have a lot of time left, which means you have a lot of time to work on homework, so it is an extra credit day. Yay. All right, everybody send us off.